To grasp the importance of tennis biomechanics, just think about the challenge of hitting a tennis ball. First of all, we have to see the ball coming off the opponent's racket. Then we have to judge the speed, spin, trajectory, and most important, the direction of the tennis ball. We then have to adjust quickly and move around the ball. As we prepare to hit, our body is in movement. The ball is moving and maybe spinning, and the racket is also in motion. We need to coordinate all these movements in approximately half a second so that the ball is struck near the center of the racket in a manner to produce the desired spin, speed, and direction for our return. A mistake in any of these movements can create an error. The principles of biomechanics we will discuss are Magnus' force, linear kinematics, and Newton's laws. First of all, Magnus' force is a lift force that acts on a spinning projectile. The spin creates a region of relatively low velocity and high pressure on one side of the projectile, and a region of relatively high velocity and low pressure on the opposite side. Secondly, linear kinematics helps us calculate displacement, velocity, and acceleration. Lastly, we will discuss Newton's laws, specifically the third law, which states that for every action there is an equal and opposite reaction. This law describes how forces always come in pairs, meaning that anytime objects are contacting each other, they are exerting a force.
A topspin shot is hit by sliding the racket up and over the ball as it is struck. This puts forward spin on the ball. As the ball moves forward through the air, the spin of the ball is going the opposite direction of the air on the top of the ball and going in the same direction of the air on the bottom of the ball. This creates a high pressure on top of the ball and low pressure under the ball, causing the ball to dip down. The dipping of the ball causes the ball to strike the ground at a lower angle than a flat shot does. This causes the ball to jump towards the opponent as they hit it, making it more difficult to hit. A backspin shot requires a player to strike the ball in a slicing motion. This causes the ball to rotate backwards. As the ball travels through the air, the spin on the top of the ball is in the same direction as the air flowing over the ball. This causes a system of low pressure. The spin on the bottom of the ball is opposite the flowing air, creating an area of high pressure. These differences in pressure causes the ball to rise. When the ball strikes the ground, the backspin of the ball causes the ball to bounce up at a larger angle than of a normal shot. This causes the ball to pop up sharper than an opponent may expect, making the shot more difficult to send back.
The forehand is struck from the dominant side of the body by swinging the racket in the direction of where the player wants to place the shot. A forehand relies on a kinetic chain of events. The segments of the body act as a system of chain links whereby the force generated by one link or body part is transferred in succession to the next link. Note the player's body as it acts like a spring. When you stretch a spring, there is a certain amount of tension and potential energy that builds up, and if you let go, the spring returns to its former position with force. Therefore, if you rotate your body, transforming it into a coiled spring, your body wants to uncoil as a reaction force to the applied tension, causing additional force when you swing to hit the ball. The backhand is struck from the non-dominant side of the body by bringing the racket across the body and swinging the racket away from one's body in the direction of where the player wants the ball to go. Kinematic analysis can help us calculate forces and compare forces exerted on objects. The force of the racket on the ball can be easily measured if we take into account Newton's third law of action-reaction coupling forces. According to Newton's second law of acceleration, the summation of forces acting on the ball and racket system is proportional with the ball mass and acceleration. Since the kinematical analysis allows us to measure acceleration values, by using the well-known Newtonian equation, force equals mass times acceleration, and solving it backwards, we can find the force magnitude acting on the ball at impact.
A drop shot is created with a slicing motion of the racket. A drop shot is used to make a ball go a very short distance. This shot makes the ball drop just on the other side of the net and to bounce up with a steep angle. This happens due to the spin on the ball created by Magnus force. The slicing motion of the racket puts backspin on the ball, subjecting the ball to Magnus force of backspin. This creates high pressure under the ball due to the same direction of the airflow in the ball spin. This also creates low pressure on the top of the ball due to the opposite direction of the ball spin in the airflow. This forces the ball to rise steeply and then drop suddenly, forcing your opponent to run to the net to save the shot. A lob shot is an effective shot to follow a drop shot with. This shot is used to place the ball far in the back of the court when an opponent is near the front of the court. The large parabolic trajectory of the shot gives it a large maximum height and a large horizontal distance. Using linear kinematics, we can see how the maximum height and the distance the ball travels are directly related to the velocity at which the ball is hit. Using the formula delta H is equal to velocity initial times time plus 1/2 acceleration time squared, and setting the time to be 1/2 the time the ball is in the air, we can calculate the maximum height the ball travels. We can also see a direct correlation between the velocity at which we strike the ball and the height the ball travels. If we increase the velocity, we will also increase the height. Using the same formula, but using delta x for distance traveled instead of delta h, and using the total time the ball is in the air, we can calculate the maximum distance the ball travels. We can also see the same direct correlation between the velocity at which the ball is struck and the distance the ball travels. As velocity increases, so does the distance the ball travels. This is important to consider so that you use enough velocity in your swing to give the ball enough height and enough distance to force your opponent to run to the back of the court to return the shot.